Find a general solution of the following non-homogeneous differential equation. So we have something on the right hand side, not only 0. That's why this is non-homogeneous. So the solution will be given by two parts. First, we consider the corresponding homogeneous, and the solution we get is called complementary solution. For that, we take the right hand side 0 and find the characteristic equation. Here d means just the derivative, so d is in fact d over dx, that's the notation. So the characteristic equation here is d is now r squared plus 2r plus 2 equals 0, and we solve this cubic equation. So times, so either r equals 0, so we get 1, or r squared plus 2r plus 2 equals 0, which is a quadratic equation, so we need to solve using quadratic formula. So r equals negative b plus minus square root of b squared minus 4ac, 4 times 2 8 over 2a, that is negative 2 plus minus 4 minus 8, negative 4, square root of negative 4 is 2i over 2, separate into two fractions. So negative 2 over 2, that's negative 1, plus or minus 2i over 2, just I. Okay, so we have r equals 0, r equals negative 1 plus I, and negative 1 minus I, three roots. So based on those three roots, we have three solutions. So solutions, we can say y1, so e raised to 0x, which is in fact 1, and y2 is equal to, these are complex roots, so e raised to negative 1x, cosine is 1i, so 1x cosine x, and third will be e to the negative x sine x. Okay, these are the three solutions coming from the homogeneous part, and we write down the complementary solution from these three. Then yc is c1 y1 plus c2 y2 plus c3 y3, which is c1 y1 is 1, so c1 plus c2 y2 plus c3 y3 is e to the negative x sine x. Okay, next we need to find a particular solution. For we use the method of undetermined coefficients. Look at the right hand side, we have 3 e to the x plus 5x squared. In fact, we have two terms here, so we need to make an initial guess for first term as well as for the second term. So we let yp be based on this exponential function. 3 doesn't count, I mean we can always write another constant. Ex is ex itself and a constant a, provided this is not already a solution. Look, we have 1 e to the negative x cosine x, e to the negative x sine x, so there are three solutions and ex is not here. Even if it were e to the negative x, that would not be a solution. So the first part is just a e to the x plus. Now second part, we have 5x squared, which is in fact a second degree polynomial. X squared means second degree polynomial. Now we need to write a general second degree polynomial, x squared, so a is used, so b x squared plus cx plus d. This is a second degree, general second degree polynomial, and this is a linear combination of three solutions. A is 1, d times 1, 1 x and x squared. Now this would be good as long as we don't have a solution here. So d times 1 is a solution, just 1 is a solution, 1 x and x squared, but 1 is already there, so we need to multiply this by x. Now we get ax dx, cx squared, bx cubed. So ax squared and ax cubed, ax squared, ax cubed, and none of them are here, so this is good. So we need to multiply by x. Next, what we're gonna do is now we need to determine a, b, c, and d. For we find first derivative, second derivative, third derivative, and plug in here. This is in fact d cubed, third derivative, plus 2d squared, second derivative, plus 2d. Okay, this first derivative y equals this. So let's find the first derivative, aex itself. This is in fact bx cubed, so derivative is 3bx squared. This is cx squared, so the derivative is 2cx. It's dx, the derivative is d. Let's find the second derivative, aex is itself, plus this is 6bx, plus this is 2c, plus 0. Let's find the third derivative, that's aex itself, plus 6bx, 6b. Now we plug these into the original differential equation. Plug these into the differential equation. We had in fact, if we distribute d inside the operator d, not the constant d, operator d, we had d cubed plus 2d squared plus 2d y equals something. So d cube means third derivative, d cube y means third derivative, which is here aex plus 6b plus 2d squared, so 2 times second derivative. Let's multiply this by 2. So we're gonna multiply this by 2, so 2aex plus 12bx plus 4c plus 2d, multiply dy means derivative, this by 2 again, so 2a ex plus 2 times 3 6b ax squared plus 2 times 2 4cx plus 2d. That's the left hand side, is equal to, we had 3ex plus 5x squared in the right hand side. Okay, now from this equation we should be able to find the unknown constants a, b, c, d. Okay, so let's combine like terms. So here is we have here ex, here is ex, here is ex, so we can add them, 2a, 2a, 4a, 1a, 5a. Okay, so 5a ex. Now 6b constant, 12bx, 4c. So highest power is 6bx squared. So let me write that here, 6bx squared. Let's look at with x. So 12bx plus 4cx here and here. Okay, 4cx and 12bx. We can factor b out. So sorry, x out. 12b plus 4c. 12b plus 4c x plus remaining constants 6b plus 4c plus 2d is equal to right hand side 3ex plus 5x squared. This implies we are saying this left hand side is equal to right hand side. That means the corresponding coefficients should match. Ex, the coefficient is 3, ex 5a, so 5a should be equal to 3. Here is 5x squared, so coefficient 5 should match 6b. Okay, and there is no x term, that means 12b plus 4c should be 0, and same thing, there is no constant term, that means 6b plus 4c plus 2d equals 0. Now we solve these equations for a, b, c and d. Then we get a equals 3 over 5, b equals 5 over 6, plug in b is 5 over 6, so 12 times 5 over 6, 6 goes to 10, move over, divide by 4, so we get c equals negative 5 halves. Again plug in b is 5 sixths plus 4c, c is negative 5 over 2, and you can solve for d, and d comes out to be 5 halves. Then we get a particular solution ypx, that was, if you go up then you will see aex, so a is 3/5 ex plus bx square plus cx plus dx, so bx square, so 5 over 6x square plus cx, so negative 5 over 2x plus d times x. That's a particular solution. And the solution of the differential equation y is given by ycx, a complementary solution, plus ypx. And you can write and simplify, but I would say where ycx and ypx are as above. Okay, they are already found. In fact, you can write those two solutions, and there might be you might be able to simplify. Okay, final.